it going, everyone? My name is Steven, host of the ACC Podcast from Horizon, coming at you once again with another episode, getting behind the mind of another great, super intelligent founder, Grigore Roșu. He is the founder and CEO of Runtime Verification, but primarily what brings us here today is to get behind the mind, hear his story, and focus in on Pi Squared. He is the creator, the inventor, and he is here to give us a look, give us some insight, and hopefully broaden our minds of the entire Web3 space and how to onboard the next million developers. So, Gregory, thank you so much for being here. How are you doing today?
Hey, thank you for having me. Good. How are you?
Yeah, I'm doing really well. It's just another day in 2025. It seems like every day we open up the internet and there's political news and there's tech news and everything is changing day after day. And I'm sure that that's something that you have to keep on top of and always kind of on the cutting edge of a technology such as Web3.
Yep, certainly. Everything happens so fast in Web3.
Yeah. And for those who are just participants in the Web3 space, such as myself, a huge advocate, I am spending pretty much every day just trying to dive deeper and understand this on a deeper level. So myself, I would not call myself a developer by any means other than the developing relationships. But your goal, your mission, as we'll get into with Pi Squared, is all about developing. Rather, your mission is all about enabling developers. As I mentioned in the intro, the objective to onboard the next million developers. That's quite a high level concept, a big, lofty goal. But when you think about what Pi Squared is doing, simplifying the language and enabling these developers from Web 2 to really seamlessly come in and become Web 3 developers, it's not something that will take time. It really seems to be something that could potentially happen overnight. So very excited to dive in. But before we kind of get into any more of the technical nitty gritty, I want to just kind of start with a look at you, given that this is Founders Stories. I want to understand a little bit of your background. Who are you? Some context, and really just give the viewers an opportunity to kind of understand Gregory.
All right. Thank you so much, Steven. Well, I'm originally from Romania. I did mathematics and proving correctness of everything and playing chess and Go in Romania. Then I came to the United States in 96 for PhD. I did my PhD at UC San Diego. And then after my PhD in 2000, I joined NASA as a research scientist. And my goal at NASA was to use the mathematically grounded techniques that I developed during my PhD and many others developed to improve the quality of mission critical software. And while at NASA, I learned that there is room for what now we call a language framework, which is like a meta programming language, like a language of languages that allows you to implement other languages in it. And then with that, you can verify, prove properties about programs in any programming languages using the same machinery. It's like having a hammer that can nail all the nails, all the programming languages, all the programs in programming language, all the programming languages. And then I realized that I need a group, I need a lab in order to implement this dream. So I moved to the University of Illinois, Urbana-Champaign, as a professor. And this is a big university with lots of students, lots of talented students. And I built a group, about 20 PhDs and postdocs. And we built a K framework. And then in 2010, 10 years later, I started Runtime Verification, which is now one of the major security auditors in the Web3 space, using formal verification based on the K framework. And in 2024, 1 year ago, I started Pi Squared with a different goal than runtime verification, namely to have programs and protocols be designed in a way where they are correct by construction or correct by design, where there is nothing to prove mathematically anymore about the correctness of these systems because they are already correct by the way they are built. And then I moved completely all my energy into pi squared. Runtime Verification now has a different CEO. I'm the founder of Runtime Verification, but there's a different CEO now. I'm putting all my effort and energy in pi squared. But I'm also a professor at the same
Right.
time, but with a reduced norm at university.
I love that. And I didn't even mention it. There's so many things that I could mention in the intro, but I really applaud the fact that you are a professor at the University of Illinois. The idea of really enabling developers, as we discussed in the intro, as I introduced you as, really begins when students are students, right? And a good student never becomes not a student, right? So the idea that putting
Yep.
yourself in a position where you're teaching others, although I've never gotten into the deep aspects of computer scientists and everything. Anytime I have had the opportunity to teach somebody in college, I was in finance, and something about microeconomics really just intrigued me so much. And it was fun going to class, but there was some incentive provided by the professor where we got some extra credit, some extra points for teaching our peers, are teaching our fellow classmates. And I'm not sure if it was about the extra credit or what it was, but every class to me really began a mission for me. How do I really understand something so that I can go on and teach it and reinforce that knowledge for me, understand where the gaps were in my own understanding of a particular topic. So I mean, I'm sure that comes up often for you, perhaps as a professor, but I guess just kind of out of curiosity there, whenever you find yourself in the front of a lecture, in front of all these eager minds, what are some of the main things that you feel are kind of hardest for some of your students to grasp? And feel free to touch on some of the things that you do find yourself teaching these days.
I think the hardest topics tend to be those around deep mathematical concepts in the end. However, there are ways to present them where they can be fun. Um, in particular, actually, Web3, it's all about, and the correctness of Web3, it's all about
Mhm.
mathematics. But you can understand the importance of the correctness even without understanding the mathematical techniques. But to me, the what really works in class and what keeps me doing it, because I don't really have to. I can retire if I want to, because I have 20 years of service from the university, and they are very generous. I can retire at 50. They don't care. Um, but I don't want to because it's so
Yeah.
fun to be a professor. And what makes it fun for me is not pretending. I'm not pretending I'm a professor. I'm not pretending I'm above the others. I'm simply um, dissolving myself into the problem at hand, and I try to be equal with the students mentally, and try to get excited each time together with them about the problems. Why is the problem interesting? What excited me the first time when I looked at this problem? And students really like that. Actually, there were two students who are pretty famous in the Web3 space now, who took my classes, who worked with me for many years, several years. One of them is Philip Dayan. I don't know if you know him. He founded Flashbots,
Very cool. Yeah.
an MEV company. And another one is Ilong Lee. He founded MegaETH. They were both students of mine, and we never actually discussed in class blockchain at all. It was just the intellectual game of solving hard problem and taking challenges. And those shape you as a
Mm.
human, and then you can do amazing things afterwards. What shape those things take? No, I think that's that's not super written in stone. Can be changed. What's important is the material, right? That you have as a human.
Yeah. Yeah. So from NASA to crypto, teaching machines how to trust, what sort of things were you doing at NASA that you find really parallel and even put you one step ahead of the curve to developers these days who are deep into the Web3 space? What sort of things perhaps do you even miss from your time at NASA?
I think what I learned at NASA is that what I learned in school can really be very
Mm,
useful. Okay? That was my first job out of school,
very
actually, and I always thought in school that I'm learning all these mathematically grounded, very heavy techniques, and who knows if I'll ever need them. And then when I landed at NASA, I had to use these techniques right away. and they were even not good enough. They were not mathematical enough, not precise enough. And I had colleagues at NASA who actually didn't even want to talk to me initially because they thought I know nothing. I was not ready for them, right? But I felt that as a challenge, and then I tried to sharpen my techniques and to make them work. And eventually, we made them work. And I think I have several success stories at NASA how we found bugs in serious errors, critical errors in mission critical software,
Hmm.
in software that actually space. But then I also have horrible stories where our bugs were not fixed actually, and the spacecraft flew with the bugs in simply because of political reasons.
Yeah.
I don't even want to go into that. And actually, that was the moment when I realized that I want to come back to academia and to build these tools properly. And also, I learned at NASA that in spite of the huge need for correctness, the tools, the technology was not there yet. It
Mm.
still needed a lot of work to be perfected, to be really practical. And that helped a lot with the design of the K framework, and then implicitly with everything we've done at runtime verification now at Pi Squared, which because everything is built on that foundation.
Love that. So you've mentioned now a couple times the idea or the concept, this need for correctness. Does that have anything to do with also the idea of formal semantics, which I think, as in my research preparing for this conversation, the idea of integrity among these systems continues to be paramount, and especially when it comes to verification. I guess all of these things kind of come into their own kind of separate trilemma of ensuring that each of those things are put at the forefront of everything that is developed. And obviously, that is important whenever it comes to a system of monitoring a blockchain or a protocol of supercomputers and keeping everything in line. So, what do you mean when you say a need for correctness?
Well, I mean, there is the obvious meaning, right? If things are not correct, then they can go
Hmm.
wrong. And if they go wrong, we lose money, we lose
Right.
life
Yeah.
sometimes. So we cannot afford to have errors. Unfortunately, people realize the importance of that only after the
Mm,
fact. Same like in life, right? We realize what we had after we lose
yeah.
it. Um, and in order to talk about correctness, actually, because you mentioned formal semantics, a formal semantics is actually a mathematical definition of the computational model of the programming language in which programs are executed. Because without that, it is impossible to even talk about correctness. Right? If you don't have a mathematical definition of the programming language, you cannot say when a program was correct. You can find errors in programs by testing and seeing that things go wrong in one way or another, but you never know exactly when the program is correct. And why you want to know the program is correct? Because then you know that you can stop testing.
Hmm.
The program is correct now, and you have the peace of mind that all your investment will not go wrong. So yeah, why correctness is important? That's a very old topic, probably one of the oldest topics in computer science, and there are several Turing awards that were given to scientists for developing techniques that help us prove programs correct. It's one of the most researched areas in computer science and the most mathematically deep um, area.
So correctness is more than just a dev tool problem. I mean, especially considering that you came from NASA, where, as you said, a mistake can cost life, and that is very serious.
Yeah.
So these days, not to undermine anything that you're doing now, but whenever you're working on mission critical software, that life really truly is paramount. There's a slightly smaller edge of impact of disaster, of a mistake, of a lack of correctness, but that doesn't change the importance of what you're doing. So, what is the human cost of bugs and trust assumptions in the world of Web3? Explain how correctness is more than just a dev tool problem.
So I can, bring up all the hacks, all the bridge hacks, smart contract hacks, exploits of errors in programs. All those contribute. right? And they add to our uncertainty, or not our as Web3 developers, but as a society. Many people don't use Web3 because they are afraid. They are afraid that what if I lose my money? What if I do this? What if I do that? So that's where correctness comes into the picture. Correctness increases our confidence in these systems on the one hand, and security is part of it. Security is part of correctness. So correctness is a very broad concept, and what we do specifically at Pi Squared is to generalize the concept to all programming languages, to make it universal. So we can talk about correctness in all programming languages, not only in one programming language. For example, on Ethereum, all smart contracts are in Solidity and EVM, and there are techniques to specifically analyze an EVM or a Solidity program, but that is too little. And now there are programs written in Rust, written in Wasm, written in other languages, and we can use the same infrastructure, the same uniform approach to prove the correctness of all of them. But I think what is more important in Pi Squared, and what is new compared to many other similar companies that do formal semantics and formal modeling, is that we actually have a mechanism to reduce computation to mathematical proof. All right, and why is that important? Is because now we have a uniform way to talk about computations, which is through mathematical proofs. And this also allows us to check the integrity of computations by checking the integrity of mathematical proofs. And in spite of how difficult it might sound, actually checking a mathematical proof is quite easy. And the mathematical proof checker that can check these mathematical proofs is very simple. Think like about a few hundred lines of code that can check the integrity of any programming language. And now if you implement that as a zero knowledge circuit, what you get at the end, you get a cryptographic attestation that the program was correct. And this is for the first time done universally for all programming languages. Okay, so let me repeat what happens here. You take any program in any programming language, execute it, you get a result, say 42. And besides that 42, you also get a succinct cryptographic signature, a zero knowledge proof, that attests with certainty that that result 42 is correct. Okay, so with that, now you can implement blockchains differently. You can implement lots of things differently, and you don't need to execute programs anymore on chain. You can defer execution to mathematical provers off chain, and then take their proofs and commit the results on chain.
Okay. That's a lot of things that we very well could unpack, and that's the joy of talking to an educator with decades of research such as yourself. So, my follow-up is really just a question about the path. Was it always leading here? The decades that you spent in research, your time at NASA, developing runtime verification, was there a moment of pivot? I know that you mentioned that you're now focusing all of your attention on Pi Squared, but was it always leading here, or is it kind of a hindsight is 2020 thing where you see how every building block in your personal career has led you to the perspective that you have to solve today's problems in Web3?
Now that I look at it retrospectively, it definitely feels and is like a convergence point. Everything I've done seems to have converged here. But the path was not obvious. As a researcher at NASA, I just looked for the next interesting challenge, the next problem to solve. Then, as a professor, I always looked at finding my best students, having the best group to write the best papers, publish the next big result, implement the next big tool. At Runtime Verification, we aimed at developing the best possible software to help developers write correct, secure smart contracts and design secure protocols. And what I learned in all this struggle, if one could say so, was that we developed, in fact, the infrastructure for what we call correctness by construction now. We developed all the tools that were needed in order to actually avoid formal verification, avoid having to prove things correct, because there is no other way to execute them except in a correct way. If you develop the right infrastructure, the right execution engine, imagine that you have an execution engine of your program that doesn't let the program go wrong. Then there is nothing to prove correct about
Right.
the compilers, about the program, about anything, because it doesn't let it go wrong. And moreover, not only that it doesn't let it go wrong, but it also gives you a proof that is verifiable that the program executed correctly.
Understood. Yeah.
And now you can use that in many different places.
Yeah, so it kind of sounds like, if you build a system from the very get-go that doesn't have anything that needs to be corrected or verified, as you said, then it is a problem that doesn't exist. And to me, it kind of relates back to really the idea of building a language or a framework protocol that allows developers from all different fields, all the different developer languages, developer tools. And my understanding is this is kind of where K framework comes in. Is that right?
Yes, that's the framework I was talking about, the K framework, which is a framework that allows you to do exactly what I described, namely to define a formal semantics of a programming language like Solidity or EVM or Rust or Java. And then once you have a formal semantics, like a definition of the language, then you can push different buttons and get different tools for that language, which are correct by construction. For example, an execution engine. I can get an execution engine for EVM that executes EVM programs now according to the formal semantics of EVM. So there is no compiler or no interpreter that you have to worry about, because the execution is according to the actual definition of the programming language. There is nothing to interfere. And the execution generates a proof that is checked.
Okay.
So that's what we mean by correctness by construction. There is no place left where it can go wrong.
Yeah, and that is kind of the idea behind pi squared, is this proof of proof concept. Is that right? The pi
Yes.
squared is a
Yes.
zero knowledge proof of a mathematical proof. So is that
Exactly.
is
So the K framework generates the mathematical proof. That's what all the tools do in the K framework for all the languages. Whatever those languages do, any execution of any program in any language will generate a mathematical proof. And then that's the first pi in pi squared. Then the second pi is to cryptographically compress that mathematical proof into a very succinct certificate, which we call a zero knowledge proof. So we get a zero knowledge proof of that mathematical proof. And now we know that whatever that mathematical proof was for is correct.
okay.
And that's the basis for everything. So in pi squared, by the way, pi squared, yes, it's a technique, but also a decentralized network, where you have a decentralized network of validators that validate claims. And all the claims are, now I'm going to say it, it's mathematical theorems that come with mathematical proofs. But everything that is true is a mathematical theorem in some appropriate mathematical theory. In particular, the execution of this program evaluates to 42. That's a mathematical theorem in our setting, and the K framework generates such mathematical theorems and proofs for them. So in the pi square network, everything is a truth, a claim that comes with a proof. And the validators validate the proof, and now they settle the claim. Okay, and that's it basically. So you get claims. Think of it like a Wikipedia with verified facts. And once the fact is verified, you get like a check mark, a green, nice, big check mark. And now you know that that thing is true. There is nothing to worry about because it's true. It's been verified by a million verifiers that agreed that this claim is true. But that claim can be an execution of a program, can be a mathematical theorem, can be the fact that you are Stephen, where the proof is some, social security, document that proved that was verified by some, office, governmental office that stamped somehow cryptographically, which counts as a proof that you are Steven. Okay, so any claim that comes with a proof now can be verified, validated by the validators, and then settled. And what is different from blockchains here is that this is a set of claims, unordered set of claims, while blockchains are completely ordered, totally ordered. And the advantage of pi squared is that it unleashes parallelism. All the claims can be validated and settled completely independently of each other and in parallel with each other. In fact, there is no TPS on our network. There is no cap on how many claims per second we can settle. If we need more, we can add more validators. It's horizontally scalable. All right, and this is super critical for the new applications like AI, for example. All the AI models, they want to use the blockchain because they need to pay each other. They need to interact with users. They need to settle their computations. Your self-driving car, if it takes left, you better record that somewhere in a permanent storage, like a blockchain. But the thing is that blockchains are too slow for that. Blockchains, even the fastest blockchains do 10,000, let's say 20,000 transactions per second, even 100,000 transactions per second. Nobody does that, but suppose that they do 100,000 transactions per second. They're still too slow for the near future because we'll have millions of agents acting at the same time. They pay each other at the same time. And with our network, the pi square network, actually everything that anybody or any application or any agent does becomes a claim that is settled completely independently of the others. Nobody has to stay in line, to say so metaphorically, for anybody else, unless they are causally dependent. But if they are not causally dependent, they don't have to wait in line, which is what happens, unfortunately, with blockchains today. No matter how fast they are, there is still a line.
Yeah. Queue and transactions are energy, are funds, are resources. So let me see if I get this right. So basically, pi squared is making it possible to prove that any code did what it was supposed to do without trusting how it was run?
Yes, provided that you give me a mathematical proof. I don't care how you obtain that mathematical proof. You see? That's the beauty of it. That's the beauty of mathematical proofs. Even, pick the biggest enemy of everybody, who can, if that enemy can generate still a correct mathematical proof that the program evaluates to 42, then the program evaluates to 42. It doesn't matter who proved it.
Yeah.
Yes.
Okay. So,
But and also once that proof exists, now that proof can be verified by a million validators, and now that claim settled once and for all, and it's true. And it doesn't matter who said it; it's true because it is true.
all right.
And it doesn't matter who proved it either, because it's true because it is true.
Yeah, it's the pi squared, and the concept of squaring anything in mathematics can simply go from 1 to a million very fast. And taking these concept of proofs and proofs is something that like I said, is still kind of it's slowly eking into my understanding, and the idea of zero knowledge proofs, of basically proving that you know a secret without revealing what that secret is. And
The secret is the mathematical proof here.
Mhm.
It all makes sense, right? So if you make a claim, right, how can you prove that claim is true? Just think about it naturally. Forget everything we discussed, right? You have something, you make a claim that which it's true, right? So how do you convince me that it's true? Ideally, you can have a proof, mathematical proof, let's say, of that claim, right? And then you can convince me. But that takes time, and that proof is big.
Yeah.
And we have to meet somehow to discuss. I have to trust you, right? I need access to your proof. But now imagine that you can actually do a zero knowledge proof of that mathematical proof.
Mhm.
That mathematical proof is like the secret. But it's not a secret because you want to keep it secret. It's a secret because you don't want to send it to me because it's huge, it's big, it's hard to check, right? But if you generate a zero knowledge proof that you have a mathematical proof, then that's it. Then the fact is true without having to give me the mathematical proof.
Got it. Got it. Well, I can't say I perfectly get it, but like I said, it's a concept that I'm edging closer to. But I'd like for you to kind of explain how this actually shows up in practice. Like, what's a use case where somebody would actually feel the difference? And if you're able to dumb it down for maybe just a user of cryptocurrency versus a
Yeah.
developer, then that would be great. But this is very, applicable to the developers, the people who are writing the code itself. And it's something that is, as you said, is something that I guess is just enabling kind of almost a universal remote controller of sorts, where people can come in with any sort of code and don't have to worry about having an understanding of a different language. So, what is a use case where somebody would feel the
Well, they
difference? Uh huh.
well they if you use a programming language as a developer, you still have to understand your programming
Hmm.
language.
Right.
Right, but what is nice is that now you can use lots of different programming languages at the same time in the same application, same like in Web
Hmm.
2. In Web 3, we tend to have silos and fragmentation. Each blockchain has its own VM, its own language, its own culture,
Hmm.
its own liquidity locked like TVL, and lots of separation. And we actually vouch for unlocking all this liquidity and value and defragmentation of the space, and that happens in two different ways. One is by removing the programming language or the virtual machine as the core piece of the blockchain. The programming language doesn't matter. Let's put it this way. It doesn't mean that you don't have to understand it. As a programmer, you still have to understand the programming language, but you don't want to switch to a new programming language only to participate in a certain Web3 ecosystem,
Right.
right? So that's one way, by making it universal with respect to programming languages and the computing environment in general. And second, by actually connecting all the different blockchains, L1s or L2s, through our network, the Pi-Square network. If you go to our DevNet, for example, you can see that there are certain claims happening in our network. Remember, claims with proofs?
Hmm.
And those claims correspond to actual blocks that are being executed on different blockchains. For example, with every block on Ethereum, right, we get a claim on Pi-Square that shows exactly all the transactions in that block in the exact order they happened, the exact state before and after. So now any application that integrates with Pi Squared can see what happened on Ethereum with certainty, because that is proved, that claim is proved, without having to go to Ethereum. Okay? And moreover, it can write applications, it can write programs or business logic in a way where people can do transactions on Ethereum that have an effect on Pi Squared, whose result then is deployed on Solana.
Hmm.
Okay? And all that happens because of this, what we call bidirectional integration of Pi Squared with different other blockchain ecosystems. Right? So on the Pi Squared, we can see exactly what happened on each blockchain because we generate a claim for the block that is verified. And also, whenever a claim is settled, on the Pi Square network. Remember, like Wikipedia with a check mark that you are Stephen,
Hmm.
right? So whenever that is settled, our network will give you a proof, a membership proof. Basically, a membership proof for the fact that the claim is a truth, now belongs to the set of truths. And once you take that membership proof, which is a very, very cheaply computable speaking, verifiable artifact, is the simplest possible cryptographic proof that you can imagine. It's a BLS signature, basically, right? You get that to the blockchain, to the smart contract on the blockchain, or any application that accepts such claims that have been proved this way. And that application now knows that that claim is true, right? So this allows you to take truths from one blockchain to another without a bridge.
Mm.
You see, by simply because they are all going through the world of mathematics, where truths are the same. Maybe if I can make a metaphor or an analogy, for example, suppose that you are an architect, right? And you do a design of a building. and you use Pythagoras theorem somewhere, right, in your design because you want to prove certain things, right, some distances. Well, you use Pythagoras theorem. Pythagoras theorem may have improved using some, mathematical instruments like Euclidean geometry, but you use a completely different beast in the design of your building, right? So the fact you never think about it, well, I cannot use Pythagoras theorem because it was proved using a different language. It's not my language, right? So that's why when you go through the world of mathematics, then it doesn't matter. This trigonometry, algebra, geometry, they can all live together, right? Because it's all logic reasoning. Same here, all these different computations that happen in different ecosystems, in different blockchains now become mathematical facts. And they can, use each other same way you use a lemma when you prove a theorem.
So speaking of proving, this is all information that I think for an everyday crypto user would definitely take a bit of time to really immerse themselves and understand. In your time that
Yeah.
you've been in Web3, are you having a lot of success in helping other developers and people who are pushing the kind of the bleeding edge, the cutting edge of this technology? Are people understanding this right away, or does it kind of take any sort of rerouting of where people have come from in the Web3 space so far?
The beauty of it is that you can take advantage of it and use it even if you don't understand it. I know it sounds a bit weird, but really it's not. Um, if you are a programmer, I would give as an example type systems in compilers, right? So type systems are very advanced mathematical techniques that now are implemented in compilers. And when you write programs and compile them, you don't even realize that these advanced techniques happen and advanced algorithms are executed when you compile your program. You take full advantage of hundreds of many years of advanced research and engineering without realizing, without even noticing it. Same happens with cars, right? So now you can switch to an electric car. Maybe it takes you 5 minutes or so to adapt, and then voila, you can just use it. You don't care anymore what's under the hood, right? It takes you from point A to point B. Great. So same here. We don't have to. Now I got deep into these techniques because that was the point of this of this interview. But as a program, as a developer, you don't care. You just say, hey, I want to use Rust to write programs, or I want to use Python to write programs. Can I? Yes. All you need is to plug and play Python. And Python is this semantics, which you don't have to understand. It's just here. It's python.k, this file. Upload it. Wait a second. Now you can write programs in Python. Just like that, right? You don't have to understand the semantic framework. And moreover, we give you these certificates that each execution of each program in Python was done correctly. So now you don't even actually need to implement Python yourself. Everybody can understand it, even if they don't understand the machinery underneath. Same like with the ZK VMs and ZK proofs. People use them as black boxes without understanding really what's going on. And also, in terms of performance, everybody understands performance, by the way. People may struggle with correctness, why is correctness important, but nobody struggles why performance is
Right.
important.
Yeah.
And everybody understands the value proposition of Pi Square's network, which is, uncapped performance, unlimited TPS, because all claims are completely independent and you don't need to wait for each other. And especially the AI agentic companies that we talk to, they are super interested in alternatives to blockchains. They are very interested in Web3, where the thesis is that we have our own assets and we give access to tools and programs to our own assets. Nobody, stays between us and our assets. But you don't need blockchains necessarily for agents. What agents need, they need payments. They need to do payments. They need a payment system. They need that to be fast, really fast, and they need settlement to settle their actions, what they've done. To have permanent record of their actions. And yes, you can use blockchains for both payments and settlement, but you don't have to. And this is something they understand very quickly, and they accept because of the performance. Performance is more important than correctness as a value prop when we talk to to AI, at least, companies.
Yeah, it's almost the idea of performance as long as it's not stating any clear errors or causing any huge problems. If you can show that it is performative, then yeah, as we're kind of discussing here, there's no need to get under the hood and understand exactly how an engine works and
Yes,
how all of the pieces come together. And is that
yes,
so? I mean, it's funny because this is all about proof and proving proofs and conveying that knowledge is understood without revealing what that is. So the framework that you've developed sounds like it almost speaks for itself. And if you're able to, what sort of transaction speeds? I mean, there's some abstraction between what pi squared is. It's not a blockchain. So are we still talking in transactions per second? What differentiates what pi squared is doing from maybe what users these days are slowly learning more and more about understanding Bitcoin as a way to transact peer to peer, and then moving to Ethereum, understanding smart contracts. It seems like everything gets to be very high level, very quick. But at the end of the day, it sounds like you're with Pi Squared trying to kind of move away from some of the semantics. Let's just focus on the performance. And of course, if you're a developer, then dive into it, get into it. And hey, by the way, you don't need to learn all of these languages. You can take one language and it translates across the board. So I guess help me understand, help for users out there who maybe are just, all right, I just understand what Bitcoin is. How does this apply to everyday users? And what can we do to basically understand what is important to take away with this without getting overwhelmed with all of the under the hood semantics?
I think a first important step is to understand that blockchains, Bitcoin in particular, were invented to solve a problem that we didn't know how to solve back then: double spending.
Hmm.
Everything else was crystal clear, was known how to have coins as histories of transactions, how they are in Bitcoin, how to have decentralized ledgers up to a certain point. Um, the cryptography was definitely known. The only thing that was missing was how to avoid double spending. And that's the amazing innovation that Satoshi Nakamoto came up
Hmm.
with, which essentially boiled down to let's enforce a total order on all the transactions. Now, if we know that they happen in a total order, you cannot double
Right.
spend because it's either one or the other first. Well, very recently, 5 years or so ago, um, an important idea took shape and came from different places because that's how many great ideas come. They don't come but in one place only. People realize that something is interesting happens, and that is that a different way to guarantee um, no double spending, okay, was invented, where you don't need to total order the transactions. Okay, there was a paper published by a group of EPFL researchers, and then also another paper published by then Facebook researchers. Now they they are spread in other
Hmm.
places, where they essentially showed that you can avoid double spending with a different protocol, a broadcast protocol, where you still have a decentralized network of validators and you communicate with all of them. They don't talk to each other like in blockchains, and they get back to you with signatures. And with just one round trip message, you can uh, do transactions, settle transactions, but only payments. That's all they showed, only payments. You can settle payments without a need of a blockchain. Okay, so let me put it this way. If this algorithm was invented 10 years earlier, before Bitcoin, in 2005, then probably we would not have Bitcoin now.
Hmm.
That's a very strong claim I'm making, but I stick to it.
Yeah.
Because it solved the problem differently, much more elegantly, and very efficiently. Okay, once I saw that algorithm, I fell in love with it, and I realized that this is the new Web3
Hmm.
trend. And then what we did was to generalize that algorithm to work with any claims, not only payments, any claims, any computations in any programs, in any programming languages, basically whatever the K framework gives us, all the proofs, anything that comes with a proof. Payments are very simple claims with proofs that are just signatures. I sign that I pay you. But imagine now that you extrapolate that to any claims that come with proofs. And that's what our algorithm is. We'll call it fast set from settlement. And yeah, so it's for a user. If you write the claims as programs in certain programming languages, you see almost no difference. You have the same user experience. You write a program in your favorite programming language. That program takes some input, modifies a state, and that's it. So it's the same experience. What happens differently is under the hood. Same like the, gasoline car versus electric car.
Hmm.
But one will be a lot faster.
Right. And all the end user knows is whenever they push the pedal, the car goes, it gets them from point A to point B, hopefully in a safe manner. And I think that is what really kind of startles me about the space right now. It's as if people are building in the Web3 space, they're building these skyscrapers without a blueprint to begin with, without
Yeah.
verification.
And without a foundation, without a foundation.
Right. So, yeah, I mean, along your journey, at what point did it become clear that this was a problem that you were given a skill set to really step in and solve with Pi squared?
Well, so PySquare is a new company. It's really 1 year
Hmm.
old company. Had our first round, our seed round last year, led by Polychain. But I started thinking of all these things 20 plus years ago, 25 years
Hmm.
ago. And all my career was really a big push to advance these techniques that I firmly believed in. This is my religion, that you need a formal semantics,
Hmm.
period. Without a formal semantics, you cannot do anything. That everything is proof, everything is mathematical proof. Computation is proof. Well, that's kind of folklore. Everybody agrees with that. Conceptually, yeah, of course, it's proof. But with the K framework, we made that literal, right? And then that became part of us, me, my students, our postdocs, collaborators, right? So with the K framework, literally, any computation in any program,
Hmm.
in any programming language is a mathematical proof. And now you only need to worry about mathematical proofs. And once that belief kind of settled, pun intended, then everything else was just engineering. Let's make it work. Let's make it practical.
Hmm.
And it got to a point now where performance, not only that it matches the performance of the ad hoc manual approaches, which are not based on solid principles, but it also outperforms them.
Mm.
Because that's what happened over and over again in our history of humankind as humans, right? When we use the right approach, then performance comes. We are really good at improving performance, humans, once we understand what we need to do.
Yeah.
And that's also what happened here. Once we understood that that's the way to go, and the only thing left was performance, things became pretty streamlined.
Yeah, and speaking of streamlined, the team, including yourself, of course, is deep into the stage of DevNet. I believe by the time this podcast airs, your DevNet will be live. So, where is Pi Squared in the process? And what are some of the main challenges that you're facing, kind of being deep in research and education, and now, building a startup? Now you're building a startup, you're the face of it, having to explain likely to investors why they should care. So give us a look at what's going on these days in the world of Pi Squared, and touch on the DevNet and what can be expected in the next, coming weeks to months, shorter term.
Well, if everything goes well with our DevNet, the DevNet must be already launched by now, and you can go and as a developer and play with it, and you should be able to write applications where you are truly cross-chain, where you can have an AI agent, for
Hmm.
example, run using some TEE, trust execution environment, that signs all the transactions, and that AI agent to be paid on Ethereum. and then the result of that agent to be settled on the Pi-square network, but also on Solana, for example, right? So blockchains become like Lego pieces that you can put together in the big scheme of things. And also, you should be able to use any programming languages, and you should be able to write applications, again, cross-chain applications where you don't need to bridge assets from one to another. You should be able to write your own AI agents and execute them using trusted environments or not trusted environments, depending on the cost. And importantly, all these applications will be able to make transfers, payments at the speed of light. You don't have to wait about anything. And the first experience that, or the maybe the biggest change that you would experience as a developer, is that there is no concept of block and block time and total order on transactions. You just do your thing, push enter, and then wait a bit, settled. And once it's settled, it's true. And you don't need to wait for anybody else who is not related to what you're doing. That's how you'd experience it as a developer.
Wow.
As a user, you would not even need to see the infrastructure. Same like with the car. You don't care the engine, what's the engine underneath. Yeah. So the challenge will be, of course, as usual in Web3, the user experience, the UX, UI, UX, make sure that users don't have to suffer through all the infrastructure. But that's coming. As I said, once we know what we are doing, then engineering, performance, UI, all this can be improved.
Right. So what are some of the key components? In my research of Pi squared, I came across USL, or rather that is, USL, the Universal Settlement Layer, the Universal Settlement Layer, Universal Language Machine, and Universal Consensus Protocol. Is that still what you're referring to those as, or have you changed any of the terminology?
Well, sometimes we say universal, other times we say
Got
verifiable.
it.
So you may see VSL, verifiable settlement layer, instead of universal settlement layer, but they are essentially the same thing. The universal settlement layer is this, as I said, Wikipedia-like structure. It's like a database with verified claims, verified facts. The VCP, the Verifiable Consensus Protocol, is this extension of payments, the protocol that we call FastSet, which extends the fast pay protocol that I told you that if invented before Bitcoin would probably have changed completely the future of Web3. So we have this protocol, and we call it the VCP, the Verifiable Consensus Protocol, which essentially it's a consensus protocol, but for each claim independently, no blocks, which makes it super efficient. Actually, it's optimal. You cannot do distributed consensus faster than this. And the verifiable language machine, VLM, is essentially the K framework wrapped with cryptography. So now you can execute or make claims / execute programs in any programming languages, right? This is what will give developers, the arsenal of all programming languages. So all these three, if you look at all these three components, each of them adds strength and generality in a certain dimension, like a three-dimensional space. All right. So the USL, the verifiable settlement layer, allows us to settle claims in general. The verifiable language machine allows us to have claims which are computations in different programming languages. And once you compute, you generate a proof, and now you can settle it. And the other dimension, the verifiable consensus protocol, is what allows us to settle, to actually make all this work at the speed of light.
Okay. Wow, speed of light, it's a bold claim there. So I guess, what are you hoping?
Well, metaphorically meaning, the speed of the message is going from one point to another on the globe.
Right.
Basically.
So right now you're in testnet, is that right?
We are in DevNet,
Okay, gotcha. So
and we'll be testnet in 6 months.
understood. Oh, gotcha. Right. So your DevNet is live right now.
Yeah, should be.
Got it.
Yes.
So I guess what are you hoping to test or learn at this stage, and what progress have you been making? Are there any huge hangups or kind of back to the drawing board moments?
So we want to learn from developers and from users. So please, if you hear this and you're a developer, try to break it. Try to use your favorite programming languages, complain when things don't work.
Mm,
So we'd like to offer the best possible experience, programming experience, in a decentralized network. And we hope that the fact that it's not a blockchain will not be visible
mhm.
to you, except in very, very few applications where you can always have the option to use a blockchain because, again, our network, the VSL, will be like a universal hub. Different blockchains will be connected through this mirroring, bidirectional mirroring process. So you can always use a blockchain if you need something complex that involves writing several addresses, several storages, several accounts at the same time. These are very rare operations, but if you need those, then blockchains can always help. So, in other words, blockchains are always available to you. Yeah, so that's what we'd like to learn. And also, we'd like to see applications where people use AI agents in combination with smart contracts. Smart contracts on some blockchains, AI agents on our network, and use the payment system, the fast payment system, to pay agents, to users pay agents, agents pay agents,
Mhm.
and then use blockchains to top up maybe the accounts, the balances of the different users and accounts. So there are essentially, because of all the programming languages and all the connections with all the languages and all the blockchains and agents, sky is the limit. You just have to be creative as a developer, and we'd like to assist you and hope to make it work for you.
Yeah. So what's a world you imagine maybe 5 years, 10 years from now where pi squared quietly powers things people don't even realize? Furthermore, do you see a path where this reaches outside of crypto? You mentioned AI, but obviously the implications are far reaching into healthcare, law, supply chain, and beyond. So whether it be 5 years or maybe even 1 year, considering how quickly technology moves these days, I guess what would success feel like for you personally?
Well, of course, I would like everything to be proved,
Right.
everything that is claimed to be proved. That will avoid, at least fake news,
Mm,
but many, many other problems. Also, you mentioned hospitals, maybe government institutions, universities, right? They can all settle records on the blockchain, and it's not that they are public and therefore, have a privacy issue. No, you can always encrypt them. That's not an issue. I'm a firm believer in Web3 as a philosophy and as a principle where people own their own assets. I own my degree, my diploma, not the university,
right.
because it's mine now. And once I got it, I should be able to do whatever I want with it without anybody staying between me and my asset. Um, and Pi Square is really designed to be a seamless infrastructure for digital assets because the same algorithm that we use for payments is used to transfer assets. So it's the fastest possible asset transfer infrastructure. And I hope success for me would be that maybe not all, but lots of the digital assets will be settled on the Pi Square network because that gives them maximum optimal performance. And also universities, at least, should settle their degrees
Mm,
and transcripts and everything on this network. I say universities because they are, more open to science and to novelty. But eventually, all institutions should be able to do that. Yeah, and AI agents, of course, AI agents. I think they have no other option because blockchains are not giving them what they need. Are too slow for what they need and expensive.
mhm.
They will need micropayments. They will need to pay you a fraction of a cent for something, and they want to do that, a million per second. So, you cannot do that with blockchains. Also, another thing that we realized is that once you have the pi squared infrastructure, the promoted VSL verifiable settlement layer promoted by pi squared, whether it's pi squared or not, could be some other competitors in the future. They're still equally successful from my perspective, if that idea transcends, is that it will be much easier to implement blockchains on such an infrastructure than we implement blockchains now. Basically, we can implement a blockchain on a phone because a blockchain is going to be just a sequencer. You see, all you have to do is to take transactions from your users and put them in blocks in a line. Say, I choose this order. You can have a sequencer. You can have, a random number based deterministic sequencing, and then say, this is the next block. And that becomes a claim, and have everything else, the verification, the settlement, the change of the state, everything done by the pi squared network or the verifiable settlement layer. You don't even need a decentralized network to do a blockchain, because the decentralized network already exists now, and it's one network which can have millions and millions of nodes. And a blockchain is really just a program. Imagine like you have a computer, a very powerful computer, and you implement a program that is basically like a prompt in which you can type commands. All right, so that's a blockchain. It's just a program running on this powerful infrastructure. So I think there will be lots of blockchains without even calling themselves blockchains. It will be just applications that, like any application, goes from one state to the next, to the next, to the next, which is also what blockchains do.
Right.
I
love that. And that's the concept that brought me into the world of Web3, which even in 2017, I'm not sure if the term Web3 existed. Maybe it did, maybe in the folds of developers. But just the idea of owning assets became a concept to me that became really important. And it's now grown in such a way that, as you're mentioning, degrees should be stored on the blockchain. All data should be stored on the blockchain. It's verifiable, and the scalability that pi squared is kind of
not necessarily on the blockchain.
Right.
They need to be settled. Cryptographically.
Yeah, see, now
and decentralized.
we're at a point where the abstraction between what Web3 is, it needs to step away from blockchain, because that's something that I'm learning.
No, blockchains are an amazing application, but just one application. Same like a computer. In a computer, you have an application, like Word, Microsoft Word. You don't go and say, hey, I'm going to the supermarket to buy a Word machine. Right? You go to buy a computer and you can install the Word application or Excel or any other application. That's how blockchains should be.
So how can, for our listeners, for me here, what kind of mantras maybe can I start to kind of like think about that allow me to kind of rethink about what pi squared is doing to the Web3 space, moving away from this idea of, blockchain, because blockchain is one application of these tools. So kind of what can we kind of also help to push in terms of the narrative to get people to take a step back before getting lost in the weeds of what all these things are, kind of just realizing, go ahead.
So I would say in 2 words would be verifiable settlement. But now you need to qualify a little bit, because settlement can be settlement of payments, settlement of computations, settlement of truths that you are Steven, settlement of mathematical facts, of Wikipedia facts, of everything that comes with a proof, right? But verifiable settlement is the important thing. And now if you immediately think of blockchains, because you say, well, but that's what blockchains do. Yes, but now when I think of a blockchain, I think immediately of a total order. Transaction 1, transaction 2, transaction 3, transaction 1 billion, and a sequence, one after another. And this is inherently slow and limited. Now imagine that you unchain the blockchain completely, right? So all the claims are completely independent, same like Wikipedia. On Wikipedia, you don't care if your page or my page, occurs first, right? They are a set of facts, right? Knowledge. Same. So verifiable settlement of knowledge. And computation is just particular knowledge. Balance is particular knowledge. payments, particular
Hmm.
knowledge, right? Everything is that comes with a proof is now a claim, and it can be settled. And blockchains can be implemented on top of this.
Yeah. Right. So I guess at this point, the future is extremely bright. And I think the idea of kind of, unchaining the blockchain is kind of the idea here of the settlement idea of verified settlements
Yes,
and how that can
yes.
empower the future of the next generation of the internet. So kind of as we close here, of course, I want to thank you so much for your time. So where can listeners get involved or sign up? Feel free to plug whatever Discord or Telegram you might be
Well,
using.
anytime I'm happy to talk to anybody interested in any of these techniques. They can easily find me. Search my name is not very popular, so you'll quickly find me.
Not yet, not
Um,
yet.
on Telegram, on Telegram and Twitter, it's at Grigore Roșu or at Roșu Grigore without any underscores or anything. But best go to pi2.network,
Okay,
and through the menu you should find the links to developers page, documentation, and contact page.
awesome. I guess as we close, the last question I have is what is the next milestone for Pi Squared after this?
DevNet, testnet, and then mainnet in 1 year. And we'll do a community sale as well. We'd like the community to be part of our journey,
All right.
not only investors. And also, we are interested in finding good investors and good collaborators and good partners anytime. So, if you're an investor, please contact me as well.
Of course. I wish I could be investing personally, and I think that I'll have that chance eventually with the public sale. But all the best wishes to you and your team. I think it's, as I said already, it's spectacular that an educator such as yourself is coming along and realizing that they have solutions to problems that we face today, kind of giving people a way to be more than just a developer in a narrow field, but rather explode it, open it up. And I think that probably the end goal, although it may be unstated, is by onboarding the next million and hopefully more than 1 million developers, they can continue to bring new applications with immediate verification and elegance that users such as myself who maybe don't understand everything that's going on under the hood can use these products that solve these problems, and it's built in such a way that there is solid foundation that maybe after this is all kind of squared away and is kind of really becomes the next era of the internet. Who's to say what other problems will come along to solve? But hopefully, I guess this is the last one, and all we can do from now on is focus our resources on creativity, on how we can begin to use these concepts to bring new applications, new ideas, new creativity to users such as myself. So, Gregory, thank you so very much for your time today. I'll just give you one last opportunity to share any advice or insight that you have as the founder and kind of main, I guess, talking head of Pi Squared. If there's one thing that our listeners can kind of take away from this episode, what would you leave them with?
Do your math homeworks because mathematics is useful, um, and formal semantics in particular is the foundation of the new era of machines. Because without that, why should we trust anything?
Hmm,
Formal semantics is our anchor into truth.
love it. Well, everybody, this has been an awesome episode, one that I'll have to be watching myself a few times over and diving into each of these concepts to learn more. So go ahead and check out the description. We'll have all of those links to get connected with Grigory and Pi Squared here and put you up with some of the bright minds that are behind the next wave of Web3 that is linking everybody together, breaking down boundaries, and really unchaining the blockchain. So thank you again for your time very much. And good luck to you and your team in onboarding the next million developers.
Thank you, Stephen. Thank you for having me.
You're welcome. All right. Bye bye.
Bye bye.